hot here. Sign sheet. Thank you. Hello, everyone. How are you guys doing today? Good. It's so nice to see you guys in person. The problem is the room is so tiny and so hot. I wish they can see my room. Usually they never see the classroom. Okay, so like I said in our last class, I'm going to make a homework tab. So you see on the top, homework. When you click on the homework, it will take you to the homework page. So I already posted the homework for section 1.1 because you are done with 1.1. So the homework due for 1.1 is next week, Tuesday midnight. Sorry, not Tuesday, Monday midnight. And you have to do only 4 questions. 1D, question 2, 4, 5. And I also posted the question numbers here. 1D, question 2, 4, and I forgot 5. So make sure show the work. I'm going to pick only one question to grade. You don't know which one, so you have to do all of them correctly with as much details as possible. And then if you get that question correct, you get full 10 points. If you get that one question wrong for doing the rest correctly or in details, you're going to get 2 points. Okay, so make sure you do all of them correctly because you don't want to lose 7 points for nothing, right? Enjoy, have fun. These are actually nothing much. Just writing the augmented matrix, coefficient matrix, those things. And I posted our last recording here. Click on the recording. It will take you to our page. This is our first recording. And then all the class will be below, not below, above that. And if you want to subscribe, you can go to my main page and subscribe. Okay, any question before we start our lecture? Any question, comments? And also I changed the review sheet from 1.4 to 1.5. So if you look at the review sheet, it's actually different than the last time. Last time I posted the questions from 1.1 to 1.4. I updated it, and now it's from 1.1 to 1.5. So my plan is to give you our first exam after we finish 1.5. And you'll decide 1 week before the exam date when the exam will be. Any questions? Comments? Concern? No laptop, please. Close your laptop. Remember I said no laptop, no cell phone. You can use tablet only to write notes. Okay? So, in our last class, we finished 1.1. We talked about constant matrix, coefficient matrix, augmented matrix, and going forward and backward from system of equations to augmented matrix and augmented matrix to system of equations. And then we talked about 2 types of system of equations. One is consistent, which has solution, and another one is inconsistent. It means it doesn't have any solution. So when it doesn't have a solution, there are 2 types of solution you can have. Either one solution or infinitely many solutions. And then we talked to 2 system of equations, and then I gave you one example to identify what type of solution you have. And then we talked about what are the allowed operations for working with matrices. And then we talked about homogeneous system of equations. Homogeneous system of equation means our constant matrix has all zeros. For homogeneous, there is a guarantee that you're always going to get a solution. Either it's infinite solution or one solution. And then we are done. Any question? No. So we are starting 1.2. 1.2 talks about raw echelon form, reduced raw echelon form. So when we have an augmented matrix, we would like to reduce that so that we can easily come up with our solutions. Matrix algebra.
Thank you.
What I was saying? Reduce. So augmented matrix is just the coefficient and constant together. We want to reduce that so that at the end we can figure out what is our x, y, z, or all the other variables, x1, x2, x2, all those things. So in order to reduce, we have two types of reduction. One is called raw echelon form, and one is when you reduce that even more, we get reduced raw echelon form. So how do you know which one is what? The raw echelon form has three properties or three characteristics. One is all the numbers you see, the leading coefficient, we call them leading coefficient. Also, we call them not leading coefficient, sorry, leading term, not leading term. What's it called? Leading something, leading variable. So the leading variable or the pivot, we observe them. So all those pivots or the leading variable, they have to be one. Some books says they don't have to be one, but our book says no, we want them to be one. So we want all the leading variable to be one. And then we want, if you have any row completed with with 0, it should be the bottom row. And then when you go from left column to the right column, you're going to go in a staircase direction. So if one column has only one non-zero entry, the rest is 0, then that one is your leading variable. If a row has one non-zero, the first non-zero entry, and the most of them, in the column, most of the other entries are other entries are 0, then that's the leading variable. For example, if you look at this one, in this column, we have only one non-zero entry, the rest are 0, so this has to be the leading variable. And then if you observe this column and this row, in this row, this is our first non-zero number, and in this column, this is our last non-zero number. So this has to be the leading variable or the pivot point. So when you walk from one column, you know what is column and row, right? So columns are like 10. When you hold your pen, it stands up, right? So columns are like your pens, and rows are like the columns are vertical lines and rows are horizontal lines. So when you go from one column to the next column, you're like walking in a staircase. So you from one, you're jumping to 0, and then you're going to the next non-zero number. So to go from one non-zero to another non-zero number, you have to go down and then go right. So it's like you're walking down. You're walking the stair down. So you have to walk staircase. The leading variable has to be 1. And if you have one row completed with only zeros, it has to be the bottom row. It cannot be anything on the second or third or above the last row. So these are the three characteristics to figure out whether your matrix is in a row echelon form or not. Now, a few examples. The first one, when you look at all these leading variables, this is 1, so the rest are 0, means this has to be your leading variable. In this column, these are first non-zero. So in the row, this is our first non-zero number, and in the column, this is the last non-zero number. So if you want to walk from here to here, you have to walk staircase. And then from here to here, if you want to walk, you have to get another staircase. So all the leading variables are 1, and to go from one point to the another one, you have to walk staircase. So this is in row echelon form. The next example is this one. We have one row completed with only 0, and it's in the bottom row. And then if you compare these two rows, this is our leading variable here, and this is our leading variable here. So if you want to go from one leading variable to the another one, you have to walk your staircase. So the three characteristics fulfilled. They are 1, the last column, the last row is 0, and then you're walking your staircase. Same thing here. Last row is filled with zeros, and then from one leading term to another leading term, you're going to walk staircase, and both leading terms are 1. So all three are examples of row echelon form. Who did assigning? Anybody? 28, not good. We have 35. Now the example of not row echelon form, let me start with this one. Our leading coefficient, not coefficient, I'm guessing coefficient, leading variable. The position of the leading variable is not good because this is the leading variable here and this is the leading variable here. We can only walk down from left side to right side. So if you want to go from here to here or here to here, you have to walk up your stairs. So it doesn't make sense. So you have to switch the position and then it will be in row echelon form. So this is not in row echelon form. Same thing here. We have one row completely zero. It's not the bottom row. So you have to flip it. You have to swap the two rows and then it will be in row echelon form. This one, all these leading terms, they are leading variables, they are not one. So this is not in row echelon form. Any question? Okay. Now there are two terms we are going to use. One is leading variable, which I already used a lot, and one is free variable. So whatever you do leading variable, you already have some idea what is leading variable, right? In the column, it has to be the first non-zero number, and in the row wide, it has to be the first non-zero number. So whatever you have besides those leading variable, everything else are free variable. For example, let's say you have a reduced matrix in system equations format. So we have a matrix, and then we rewrote them as an equation, as a system of equations. So here we have coefficient 1, here we have coefficient 1, here we have coefficient 1. So all three variables, they are leading variables because they are the first non-zero number in the row and the last non-zero number in the column. So first non-zero number in this row and first non-zero number in this column. So obviously this is our leading variable. Same thing here, in this row, these are first non-zero numbers, and in this column, these are last non-zero number. So x1, x3, x5, these three are leading variables. So besides these three, we still have x2 and x4. These two are free variables. So what free variables do is we can pick any number for them, and then based on that, we get our leading variables, what is x1, what is x3, and what is x5. So free variables are free. We can pick any number for them. But the leading variables, they're stuck, they're leader. So they have to follow the rules more strictly. So free leading variables depend on the free variables. We are going to work more examples with leading and free variables. Now, how do you know which one is leading variable? Or how do you select your leading variable? Leading variable has another name, pivot. Okay. So this is an example where it says, well, our leading variable doesn't have to be 1. So remember, there are two types of books or two types of authors, okay? Or two types of people. Some people believe leading variable has to be 1. The coefficient has to be 1. Some people said, well, no, it doesn't have to be 1. It could be any number. So these people believe our leading variable has to be 1. The example which I got it from, those people believe our leading variable don't have to be 1. So here, this is a leading variable, this is a leading variable, and this is a leading variable. None of them are 1. They said, well, we don't care. Well, so here it says, in this matrix, these three are leading variables, so we call them pivots. And to identify pivots, there are a few things. One is pick the column with the most zeros in it. So this column has most 0, so definitely this is our pivot for leading variable. Now this one has most 0 compared to 1, 2, and 0. So this one is our next pivot. And then use a row or column only once. So whatever you do, you can use the column or the row only once. You cannot pivot twice. For example, here, you cannot say 1 is pivot and 2 is pivot. No, only 2 has to be pivot of the leading variable, 1 cannot. Pivot on a 1 if possible. So if they are not 1, it's fine, but if it's 1, definitely pick that. Try to pivot on the main diagonal. Diagonal means when you know what is diagonal, right? When you walk from left side to the right side, you walk down. So your staircase, the corner of your staircase, these are the diagonals. This is not the diagonal, okay? If diagonal always walk from left side to the right side, it falls down. When you walk from left to the right, it has to fall down. But if you walk from left to the right, it cannot go up. So this is not diagonal, only that one is diagonal. Never say your pivot is a 0. For example, here, you cannot say 0 is a pivot, but 0 is a leading variable. 0 means there is nothing there. And then never pick anything on the right side, on the constant matrix. So these are constant matrix. We can never have a pivot there. These are the solution. You cannot have a leading variable that is a solution. Doesn't make sense. So what is reduced echelon form? So when you have a row echelon form, it means you already reduced a little bit. And then you can reduce even more. The latest you can reduce is called reduced echelon form. It means you cannot reduce anymore. That's it. This is the last step of your reduction. So a matrix in the reduced echelon form, again, if it follows 3 conditions. The first condition is it definitely has to be in row echelon form. And in that row echelon form, if you didn't say your leading variable was 1, then make sure right now in this reduced echelon form, you have all those leading variables to be 1. Make sure you have that. So you already have this in rational form, you can ignore the second step or second characteristic. And then the last thing, which says our leading 1 is the only non-zero entry in its column, which is not always true. If you have infinite solution, this doesn't make sense. Okay, this is true only when you have unique solution. So what it says is this one. Your leading variable, they have to be the only non-zero number in each column. So this one is the only non-zero number in the first column. This one is the only non-zero number in the second column. This one is the only non-zero number in the third column. So this is telling us that this is definitely in a reduced echelon form. But you are not going to get this always. This is true if you have a unique solution. Means only one number for x1, only one number for x2, only one number for x3. Then it's true. But look at here. This is actually a 3 by 4 column, 3 by 4 system of equations. So we have another column that is not a solution column. So if you observe here, in this column, we have to have one of them leading variable. They don't have anything leading variable. So all of these are just numbers, and it's because we have more variables than number of equations. When you have more variables than number of equations, you have a problem. Either you're going to get no solution or you're going to get infinite solution, one of them. So we have more variables, so x1, x2, x3, x4. We have 4 variables, but we have only one equation, 2 equations, 3 equations. 4 variables, 3 equations have a problem. So that's why the last one doesn't make sense. But still, if you compare the other 3, this is in reduced row echelon form. If you look at this one, they're almost same, but they are not same. The difference is we have 1, 0, 0, 1, 0, 0. The first column is same. Now here we have -1 above this one, and here when you reduce, it's only 1, and the -1 turns into 0. So this is in row echelon form for many reasons. One reason is all the pivots are 1, and then walk from one leading variable to another leading variable, you have to walk staircase. So they have leading variable 1, and you are walking staircase. So this is in row echelon form. So when you have this, you are done for rational form. But if you want to reduce more, we can reduce more, and then it comes into this. And now this one, no way I can reduce more. Impossible. It's impossible to reduce this more anymore. Okay? So that's why this is reduced rational form, and this is only rational form. All this may seem funny to you guys, like hard to understand, but when you do some examples, you'll see what's going on. Now, few examples. Identify which of these are in reduced echelon form. We care about reduced echelon form because when you have them, you don't have to reduce them anymore. You get the solution right away. So, is this in reduced echelon form? What do you think? Look for the three characteristics. If you have zeros, all a row with all zeros, it has to be on the bottom. Do you have this? Yes. If you have leading variables, they all have to be 1. This is our leading variable. This is our leading variable. And in this row, this is the only one we can pick. We cannot pick this one or this one. So we have 2 leading variables. And what are they? 1 or not 1? They're 1, right? So we have leading variables 1. We have the bottom row 0. And walk from one leading variable to another leading variable. How are you going to walk? Staircase. So is this in reduced echelon form? Yes. We cannot reduce anymore because all of these are zeros. So how can you reduce 1 or 2? It's not possible. This one, is this in reduced echelon form?
No.
Why not?
Because it's not in row echelon form?
True. And why not?
It doesn't follow the rule that so it's not in row echelon.
Which one failed?
The first one, not in row echelon form.
But in row echelon form, there are 3 characteristics.
Oh.
So which one failed?
That the leading
leading variable is not 1. See, this is not 1, this is not 1, this is not 1. So leading variables, they're not 1. So it's not in reduced, it's not in row echelon form, and definitely not in reduced echelon form. How about the last one? Yeah. Why not?
also not in row echelon form.
Which characteristic failed?
The leading variable isn't the 1 for all of them, and for the last one, it's not a 1, and also it doesn't follow the diagonal.
The staircase. Yeah, it doesn't follow the diagonal. It's not in row echelon form or reduced echelon form. We can, when you have 2 numbers on top of one another, we can definitely reduce them more. So either we can make this 0. If you multiply this by 2, so you multiply this by -2 and add with this number, one of them has to be 0, right? -2 plus 2 is 0. So one of them will be 0. So we can reduce more. So it's not in reduced echelon form. So remember the 3 operations, 3 allowed operations. One is we can swap any 2 rows. We can multiply any row by any non-zero number, or we can multiply one row by a non-zero number and add with another row. So if you multiply this row by -2 and add with this row and make this a new row, you get 0 here because -2 times 1 is -2. If you add with +2 and this becomes the new row 2, then 1 becomes 0. So we could reduce. So this is not in reduced echelon form. Okay, more examples. First one, what do you think? Is it in reduced echelon form? Can you reduce more? We can reduce more because see, we have 2 numbers top of one another. So obviously we can multiply this by something and we can get rid of this one. So multiply this by -2 and add with this one, this 4 will become 0. So this is not in reduced echelon form. How about B? Why not? Which condition failed?
With zeros, the row with zeros.
Row with zeros has to be the bottom row. So this failed the 0 row condition. And how about this one? Is this in reduced echelon form? Yes, we cannot reduce anymore. Here we cannot multiply 0 by anything to get rid of these three. Impossible. And these are already reduced. So this cannot be reduced anymore. How about this one? Why not?
The variable is not studying, like it's not following the variable.
True, but do you have any other non-zero number besides 1?
No.
Then you have no option. If you have other numbers besides 1, then probably you could swap. But here, everything else is 0, only one non-zero number. So its position doesn't matter. We cannot reduce that anymore anywhere. How about this one? Why not? The 3 shouldn't be 3. It should be 1, and then we can actually reduce them. Whenever we have two numbers top of one another, most of the time we can reduce them. How about this one? The last one. Is this in reduced echelon form? Why not? Which condition fails?
It could be reduced with more.
See, the pivot is not staircase, the leading variable. So you have to swap these two rows, then you can become probably reduced echelon form. Actually, raw echelon form. Because if you have 3 numbers top of one another, definitely we can reduce them more. Okay, so these are the answer. First one is reduced echelon. It says reduced echelon form, but I think it's a typo. Because we can reduce the 4. So probably this is not right. Not. And this one should be reduced echelon form. Oh man, my bad. These are the answer for the first page. Here. ABC. So the first one is in reduced echelon form. Second one is not. Third one is not. And then this 6 is the bottom 2 rows. Raw echelon form is A, C, D. So A, C, and D, these are raw echelon form, but not reduced because you can reduce more. And then reduced raw echelon form is C because you cannot reduce, and D. So besides C and D, B, C, or not B. Besides C and D, everything else are not in reduced raw echelon form. If you didn't understand anything, don't worry. You're going to understand later when you do some, when you really actually do some examples on converting system of equations into reduced echelon form of the matrix. Now, solution matrices. Okay, so even if you have no idea about your system of equations to begin with, just by looking at the solution matrices, we can actually figure out how many solutions they're going to get. Are they going to have a unique solution or infinite solution or no solution? So to figure them out, there are some tricks. First one is if you have all the variables, all the coefficients are 0, but suddenly the solution, remember, the right side of the vertical bar is the solution. So constant matrix. So if all the variables are 0, but suddenly you get a solution for no variable, it tells you there is no solution. It doesn't make sense. It's saying no variable equals 1. I mean, sum of none of the variable is 1. Like, doesn't even make sense. Sum of no variable is 1. Like, there is no variable, but the solution is 1. What does it mean? No variable, but the solution is 1. It doesn't make sense. So if you have all the coefficients in the coefficient matrix 0, but the solution is suddenly 1, it's no solution. And then if you have strictly staircase leading variables and no other extra columns or rows with non-zero numbers, then you have unique solutions. See here we have bottom row completely zero, so you can ignore them. And if you look at the first three rows, all three are leading variable. So if you have leading variable, then you have unique solutions. Like if you have a diagonal, which is wrong diagonal, if you have a wrong diagonal entries, and then nothing else, everything else is non-zero, I mean, zero on the bottom, and then you have all the numbers. So it's a triangular matrix basically. So it's a triangular matrix because if you observe this way, it makes a triangle. So if you have a triangular matrix, you have unique solution. So no solution, unique solution, and for infinite solution, you're going to see some examples. So let's do a few examples. For the first one, and this will be in the exam. So in the first one, do you know what type of solution we get?
No solution?
Why?
Because in the last row it's 0, 0, 1, which doesn't make sense.
So the first column is x1, second column is x2. They're telling us x1 plus x2, no x1 plus no x2 is 2, is 1. It doesn't make sense. So it's something weird, so we have no solution here. And then the next one. The last entry, the last row is completely zero, so you can ignore them. And if you observe the rest, it makes a triangle. So what type of solution do you have? Infinite solution or unique solution? Unique solution. So unique solution we have, it means each variable gets one number only. So this column is x1, this column is x2. So this is telling us x1 plus x2 is 1. And this, so this is the first column, the first row. And the second row is telling us our x2 is -1. So x2 is -1 and x1 plus 3x2, I forgot my coefficient. x1 plus 3x2 is 1. Now you may wonder how we have any solution. Well, we do have any solution because x2 is -1. So what can we do? Substitute here. So this one becomes x1 plus 3 times -1 equals 1. So x1 minus 3 equals 1. Then what is x1? 4, because we add 3 to both sides. So you see, it's unique solution. Unique means every variable have only one solution. Unique means 1, right? So every variable has only one solution. So the triangle gives us unique solution. So each variable have only one number as its solution. How about the next one? What do you think? Any solution, no solution, or infinite solution? The last row is completely zero, so ignore. We are going to ignore this entire row. It doesn't give us any information. And then if you have no idea,
Following the triangle.
exactly, it's not a triangle. We have, at the end, we have 3 variables, but only 2 equations because the last row is completely out. So we have 3 variables, x1, x2, x3, but how many solutions we have? Only 2 solutions. So more variables, but less equations. What type of solution you get? Infinite here. So for infinite solution, you still have to find out what is it x1, what is it x2, what is it x3. Because for infinite solution, you need to know what is your leading variable and what is your free variable. So this is x1, this is x2, and this is x3. Let me start with this one. This is easy. x3 is 3. So x3 is unique. It has only one solution. Now the first row is telling us we have 1x1 minus 2x2 plus 4x3 equals to 1. But we know what is x3, right? So we can substitute this x3 with 3. So we get x1 minus 2x2 plus 4 times 3 is 12 equals 1. So what is x1? We add 2x2 and subtract 12. When you subtract 12, we have 1 minus 12. What is 1 minus 12? Negative 11. So we get 2x2 minus 11. So this is our x1. So is x1 free or x1 leading variable? Which one? If you look at here, is x1 leading variable or x1 is a free variable? It's a leading variable. So our x1 is leading variable. x1 depends on x2. What is x2? Do you have any number for x2? So x2 is a free variable. It's free. It means it can be anything. We can pick any number for x2 and that x1 will be depend on that. For example, if we say our x2 is 0, then our x1 is 0 minus 11, which is negative 11. If we say our x2 is 1, then we have 2 minus 11, negative 9. So we can pick any number for x2 and x1 follows your x2. So x2 is free. It can be anything, free variable. And x1 is the leading variable. So in your homework, they're going to ask you which one is free variable, which one is leading variable. And for infinite solution, you cannot stop. You have to find what is x1, x2, x3. So here, x2 is unique, but x2 is not unique. x2 is anything. So x2 could be anything, and you have to write an equation for x1 in terms of x2. So we need 3 equations. One is for x1, one is for x2, and one is for x3. Okay? So even though they don't have unique solution, but just like unique solution, you have to have x1 equals blah, blah, blah. x2 equals blah, blah, blah. x3 equals blah, blah, blah. So for unique solution and infinite solution, you have to write your solution down. You have to write them. You cannot simply say infinite solution and stop. No. You have to find out for infinite solution what each variable is. Only for no solution, your life is easy. Just write no solution. No math is needed. Okay? Let's see. Do we have more? Yeah, we have more. Who would like to try D? Guess, is it unique, no, or infinite solution? Unique. Good. How do you know it's unique?
Because it's
Triangle. So we have a triangle here. So it's a unique solution. So for unique solution, you need to know exactly how much is x1, how much is x2, and how much is x3. So the first column is first variable, second column is the second variable, and third column is the third variable. It's better to always start with unique one. We have x3 is 2, so let's start with x3. Our x3 is 2. What is our x2?
4.
So this information is telling us 1x2 minus 1x3 is 3. Well, let me write it down if you are confused. 1x1 minus x2 and x3 equals 3. If you have no idea, this is what is happening. 1x2 minus 1x3. So 1x2 minus 1x3 equals 3. And then you do back substitution. This is called back substitution. Whatever information you get from before, you apply that, you substitute that to get the forward information. So you get x2 minus 2 is 3. So you add 2 to both sides. So x2 is 5. So this is your second unique solution. Now, what's the last line? First line is telling us what information we have. And what is x1? Sorry, what is x2? X2 is 5. And what is x3? 2. So we have x1 minus twice 5 plus twice 2 equals -2. Now do the math in your head and tell me the final answer. How much? 2? Is this correct? I'm trusting her. Is this correct? Verify. Verify her work. True? Good job. So see, for unique solution, start from the bottom and then keep going backward. That's why this is called back substitution. So is this in reduced echelon form or row echelon form? This matrix here, the solution matrix, is this in reduced echelon form or row echelon form? Row echelon form. Why? See, here two numbers, obviously we can reduce them more. Here we have two numbers back to back, top of one another, you can reduce one. Anytime you can do back substitution, it's not in reduced echelon form. In reduced echelon form, it cannot do back substitution. Okay? The row echelon form is easier because we can do back substitution. But reduced echelon form cannot use back substitution. Go ahead. Okay.
Hi guys, my name is Shahera. I'm from the Bill Standing Math Center, and I've been working at this center for some time, so I'm here to say something about it. If you guys are not familiar with the located in the East Building on the 7th floor, we have tutoring available to you guys, tutoring instructor basis, but you don't need to make your appointments to get tutored. Nothing is going on this week. Everything is up and running starting February 2nd on Monday, including the weekly study sessions that we have and the credit skill workshop. For the credit skill workshop, we have to make an appointment for navigate, and it's very important. And the sub-professor gives extra credit for attending all the credit skill workshops.
We don't.
Okay, so even if you don't, I really
Not me. We. The whole matrix algebra class, they don't.
Okay, thank you. I still encourage you guys to attend those workshops. Tutoring is available in person and virtually. If you're taking other classes that has math in it, you can still come and use the center. We have a lot of resources available to you guys. If you have any questions, feel free to stop. For you.
Anytime you don't understand anything from me, go to them.
Yes.
They'll help you.
We have a lot of tutors available. Yeah.
You can also do your homework with them.
But that's all I have for you guys. I have the flyers, so feel free to take them under your house. Here.
Thank you.
No problem. Have a good one, guys.
X1 equals to 4.
Which one? E or F?
X1, the D. Yeah.
4, not 2?
4.
Close enough. Thank you for verifying that. Okay, E. Why not? Good job. This one is telling us no variable suddenly gives us a solution 1. It doesn't make sense. No solution. How about the last one? Unique solution or infinite solution or no solution? Unique.
Following the triangle.
We do have a triangle. Now do this by yourself actually, and let me know the answer. This will be in the exam. I'm going to give 3 of them, new solution, unique solution, anything solution, and you're going to do exactly what you're doing here. First state whatever solution you have, and then find out if it's no solution, then find out each variable. What did you sign? 2 people didn't sign in. I have Hani, I have 28 minutes. Question? Someone raised it. Question or answer? Answer? Anyone else didn't sign in? Okay. So go ahead. X3 is 2. X2 is 3. Is it 3, right? X2 is 3. X1 is 5. Anybody else has anything different than this? No? So X1 minus X2 plus 3, X3 is 8. This information is telling us, X2 plus, let me make sure we got this. X2 plus 2, X3 is 7. And the last line is easy. It's telling us X3 is 2. So substitute X3 with 2. That will give you X2 is 3. 7 minus 4 is 3. So this is 3 and this is 2. That will tell you your X1 is 5. Any question? So make sure you know homework, show all the work. Don't just give me X1 is this, X2 is X, this is. Show your back substitution. Any question? So whichever has solution, we call them consistent system of equations, and whichever doesn't have a solution, we call them inconsistent system of equations. So this is the answer. Now, the 2 methods of reducing your matrices. One is called Gaussian elimination. If you want to convert your augmented matrix into row echelon form, this process is called Gaussian elimination. And then if you want to reduce completely, we call that process Gauss-Jordan elimination. It's the same thing. If you stop in the middle, it's called Gaussian elimination. But if you go all the way to the reduction, then it's called Gauss-Jordan elimination. So Gauss-Jordan elimination gives you reduced row echelon form, and Gaussian elimination gives you only row echelon form. So row echelon form is like you're stopping in the middle and you get lazy. And then reduced row means you're working all the way to the final result. How these 2 methods are different, both somewhat similar. The only difference is in Gauss elimination, when you get row echelon form, you get the upper triangular matrix. So we did few examples already. You got triangular matrix, and then you use back substitution to get the solution. So if you stop at your upper triangular matrix, then it's Gauss elimination. And if it's almost like a diagonal matrix, like if you have a diagonal and everything else non-zero, then it's Gauss-Jordan elimination. So Gauss elimination is like this format. So you have a triangle here. You have a solution, you have a triangle, and then you use back substitution. And Gauss-Jordan is like this 0, 0, 0, this 0, 0, 0, this equals something, something, something. So you have the diagonals and non-zero. It's not always, you will not always get a diagonal matrix, but this is most of the time you're going to get a diagonal matrix. If you have unique solution, definitely you're going to get a diagonal matrix. But if you have infinite solution, then you're going to have some number above your diagonal. Now this is an example with all the steps. I'll skip this. We have a very bad looking matrix and it doesn't have any bar. Even if it doesn't have any vertical bar, you assume you have a vertical bar here. Why do you assume? Because it says solve the system of equations using these two. So most of the time, if you don't have homogeneous system of equations, they're going to tell you just solve it. If it's a homogeneous system of equations, they're going to tell you solve the homogeneous system of equations. So when you have homogeneous, it means the last column has all zeros. So probably they're going to omit that. So they didn't specifically told us this is a homogeneous system of equations. So we have to assume the last column is a constant column. So we are going to reduce a 4 by 4 matrix. So we have 4 rows and 4 columns. 4 by 4. So we have 4 variables, 4 equations. So most likely we are going to get a unique solution. And we do have a unique solution. X1 is -1, X2 is 2, X3 is 1, X4 is 3. So how you are going to reduce? It's too big, so we're not going to reduce. But what they did, 0 is 0 here, but 1 here. We want to start with 1, the first row, first column. The first step, swap them. So switch row 1 with row 2. This is the first step. And when you reduce, our goal is always something like this. We want to get a unique solution. This is our goal, to get a unique solution. We may not get it, but it doesn't matter. Our goal is to get a unique solution. So the unique solution has a format 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So a diagonal matrix. Our goal is to have a diagonal matrix. If we can't get this, then whatever we have on the right side, that is the solution. So our goal is to do something here, the 3 allowed operation, apply them, and convert this matrix into this matrix. If you can do that, then all these are going to give you the solution. So here, using all these rules, all these steps, you can convert this matrix into this matrix. So you can try them actually at home. So first, they're switching row 1 with row 2, and then they're changing row 3. This row 3 is the current row 3 times, minus twice the new row 1. So this will change this 2 into 0. And then we want to change this one. So if you just subtract the new row 1 and row 4, this 1 will turn into 0. So when you reduce, your goal is to reduce column wise. So make 0, 1, 2, 2 into 1, 0, 0, 0. Once you're done with one column, then proceed to the next column. Convert the next column into 0, 1, 0, 0. So do whatever you need to do to make this column into this column. Let's do something easier. I'm going to skip this. It's better to do an example. Can I flip my pages? Okay. Let's start with this example. We want to reduce so that we get a unique solution. So our goal is to convert this into, we have 1 variable, 2 variable, 3 variable, 1 equation, 2 equation, 3 equations. So you have 3 by 3. So we're supposed to get a unique solution. So we want to get 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. And then our solution will be these numbers. So goal. Our goal is to convert that into that. That is our step 1. What is our step 1? Good job. Convert your system of equations into the augmented matrix. Who remembers the augmented matrix? Volunteer? Go ahead.
First row, 3, 2, -1, 4.
Mm-hmm.
1, -2, 2,
Mm-hmm.
11, 1.
So do whatever you need to do, applying the 3 allowed operations and convert this into that matrix. So that means we want to have 1 in this position. We don't want 3, we want 1 in this position. What can we do? Good. We are going to switch these 2 rows. So step 1, row 1 to row 2. This double A arrow means swap them. So we get a new matrix. 1, -2, 2, 1, 3, 2, -1, 4. And we're not going to do anything with the last row. We keep them. So we swapped row 1 and row 2. So we got 1. We have 1 here. So our first number is satisfied. And then we want this 3 to be 0 because we have 0 here. That means we need to change our row, second row. So the new row 2, we represent that by row 2 and a star mark, means the new row 2. What can you do with this old row 2 to make into new row 2? So row 2 minus 3 times row 1. You multiply this by -3 and then add with +3, is still turning to 0. Good news, you can change more rows at a time. You don't have to change only 1 row. That means you can also change this 11 into 0. So we want this 11 to be 0. So we need to change the row 3. So we are going to get a new row 3. What can you do so that this 11 will turn into 0? Row 3 minus 11, row 1. So if you multiply this 1 by -11 and add with +11, this 11 will turn into 0. Now, I like to do my work so that I can see the final result. So I'm going to actually do the work here. Row 2 is 3, 2, -1, 4. And if you multiply row 1 by -3, we get -3, +6, -6, -3. So this operation, I'm writing row 2 here, and then 3 times -3 times row 1, -3 times row 1 is here. Add them together, we get 0, 8, -7, 1. So this is our new row 2. Now I'm going to do the same thing for the new row 3. If I see things, then I can write them easily. So current row 3 is 11, 2, 1, 14. we are multiplying row 1 by negative 11. So row 1 is here. 1 times negative 11, negative 2 times negative 11, positive 2 times negative 11, and 1 times negative 11. So multiply all of this by negative 11. We get negative 11, 22, negative 22, and negative 11. When you combine them, we get 0, 24, negative 21, and 3. Let me know if you find my mistake. I always make mistake in this. So I'm going to rewrite the new matrix. In this new matrix, I did not change the first row. So 1, negative 2, 2, 1. We changed second row and we got 0, 8, negative 7, 1. We changed the last row and we got and 3. If you observe, we completed our first column. We wanted to get 1, 0, 0. We do have 1, 0, 0. So you move on to the next column. And when you go, you always start from the bottom, okay? Don't try to make this negative 2 into 0. Instead, make the bottom into 0 and the middle into 1. So start from the bottom. So we have 8. How can we get rid of this 8? Sorry, not get rid of. We want to make this 8 into 1. So what can we do? If you do that, then this 0 will change. All you have to do is divide this by 8. I think you have a problem because we don't do want it fraction. But you have no choices. Or we can actually swap these two. No, we're going to get fraction anyway. Even if we do swap, we get, you have to divide this by 24. Then this two becomes fraction. So you have to work with fraction anyway. No choice. So in order to convert this 8 into 1, because we have 1 here, our new row 2 will be current row 2 divided by 8. At the same time, we can change this 24 into 0. What can you do so that the 24 becomes 0?
Don't those rows equal each other? Because if you multiply the second row by 3, you get 24, and then the negative 7 times 3 is negative 21.
So we can make this 0 easily by adding this with negative 3 times that, right? So we keep our row 3. Our new row 3 is current row 3 minus 3 times row 2. 3 times negative 3 times 8 is negative 24. If we add with positive 24, it will turn into 0. 3 times row 2. So this is easy. I'm not going to do the math. I'm going to do the math in my head. But this one, let me show the work. And let me make it smaller. Negative 3 row 2. So our current row 3 is 0, 24, negative 21, 3. Now we are multiplying our row 2 by negative 3. So when you multiply this row 2 by negative 3, you get 0 times negative 3, 0 times, negative 3 times 8, negative 3 times negative 7, and negative 3 times 1, negative 3. When you add, what do you get? So our last row is entirely 0. So now let's write the new row, new matrix. We didn't do anything on the first row, so 1, negative 2, 2, 1. We divided by second row by 8. So we get 0, 8 divided by 8 is 1, negative 7 divided by 8 is a fraction. And we have 1 divided by 8. And the last row, after the reduction, it's entirely 0. So this matrix, is this in row echelon form or reduced row echelon form? You think it's reduced row echelon form, right? Let's see if two numbers type of one another. We can actually reduce more. So we cannot reduce this one because if I try to reduce this, what can we? Let's see. Can we make -2 to 0? Without changing our one. Can you do that? Let's see, row 1. So we keep our kind row 1. And what can you do? We definitely cannot use third row, it's out. So you have to use second row. What can you do with the second row so that this -2 turn into 0? 2 times row 2. So plus twice row 2. And let's do the math. Our current row 1 is 1, -2 to 1. Twice row 2 is 0. 2 times 1 is 2. 2 times -7, 8. 2 goes to 8 4 times. So you get -7 4. And then we have 1 8. 2 times 1 8. 2 goes to 8 4 times. So you get 1/4. So this is our operation. Now we're going to combine them. 1 plus 0 is 1. Plus 2 minus 2 is 0. And now we have 2 minus 7/4. 2 times 4 is 8. 8 minus 7 is 1. So it's 1/4. You know the shortcut multiplication and addition? You multiply the whole number with the denominator and then add or subtract the numerator, depending on your sign. So the last one is 1 plus 1/4. So 1 times 4 is 5. And then you add the top. So you get, sorry, what I'm saying. 1 times 4 is 4 plus 1 is 5/4. So this is 1/4 and this is 5/4. So let me change this. So we get the new row as 1 0 1/4 5/4 and then 0 1 -7/4 and then 1 8 and 0 0 0 0. Now, what do you think? This is reduced row echelon form or row echelon form? This is actually reduced. Why? Because even though you have double numbers, if you try to get rid of one of them, this 0 will not be 0 anymore. This 0 will be replaced by whatever we have here. So you can reduce this, but as a result, this will not be reduced anymore. Do you see my point? Like, whatever you have to do here, you need to multiply this by that, right? And you need to add the first row. If you do that, then 0 will not be 0 anymore. It will be something like that. So this is reduced row echelon form. So what type of solution you have? No solution, any solution, or infinite solution? Do you have no solution? No, because the last row is entirely 0. So no solution is out. Do you have unique solution? No, because this is not a triangle. This 0 is not 1. If it was 1, then it would be a unique solution. It's not a unique solution because at the end you have two equations, but how many variables we have? 3 variables. 3 variables, 2 equations, we have infinite solution. So give me 2 more minutes, okay? Even though you have infinite solution, but you still have to find out what is your x1, x2, and x3. So which one is free variable? Or which one is leading variable here? Is x1 leading variable? Yes. Which one is x2 leading variable? Yes. So you have 2 leading variable, then which one is free? X3. That means x3 could be anything. So let me get one page. X3 can be anything, so x3 is itself. Our x2 from here, it's x2 minus 7/4 x3 equals 1/8. So x2 is 7/4 x3 plus 1/8. And then x1 from here, x1 plus x3 is 5/4. This is plus, that is. So our x1 is negative 1/4 x3 positive 5/4. You still need to write down their equations. Did I make a mistake?
The second row. Negative 7 over.
Negative 7/8.
No. The new matrix.
So here we
No.
multiply this by 2, right?
That was in the lower matrix. The second row of that.
Yeah, but this is come from here. This is negative 7/8, we multiplied by 2. So multiplying by 2, 2 goes to 8 4 times. So it becomes negative 7/4. So this becomes negative 7/4. And then 2 minus negative 7/4, we get 4 times 2, 8. 8 minus 7 is 1. So it's 1/4.
Yeah, that one's good. Second.
This one
No. The bottom.
here,
Yes, that's the second row. We don't change the sequence. So.
we didn't change anything in the second row. Our second row stays same.
Or you do right second before there.
Thank you. Now I see. Negative 7/8 and 1/8. So this is 7/8. This is, oh no, this is 1/8, right? 1/8 and 5/4. Okay. So for unique solution, you have to write unique solution and then each variable gets its own equation. So you cannot stop by saying unique solution. You still have to keep going. Only for no solution, you stop. For unique and unique infinite solution, you have to keep going. Okay. So 1.2, I'm done. So I'm going to post the homework. This will be the homework, but I'm going to give you more time on this. Okay. So 1.2 homework will be due not next Tuesday, but the following Tuesday. So for next Tuesday, you have only 1.1. So enjoy your weekend. Have a good day.
Well, the question one, the first one, yeah? And it says run down the matrix.
For all of them.
Yeah. And what about this one? It says write an augmented matrix for each of the system that is size 3. It says there's like 1, 2, and there's no 3. So I was thinking, is it like for all of these? Okay.
And then you continue.
Okay. Then I'll for now I'll do the black one. Yeah. Okay.
It's only next.
In another country, my flight got delayed because of the snowstorm.
Okay, and there's no problem.
I saw the lecture video.
Good.
But
You're fine. Thank you for letting me know.
Are you gonna upload this like is the mic going to be recorded or just the Oh okay, thank you.